Okay, so section 4.6. This is the last thing we're going to be doing in chapter 4. It gets us into a specific type of function called arithmetic sequences. So our learning targets for today is that you can use the arithmetic sequence formula to find an nth term, and we'll talk about what that means, right? An arithmetic sequence equation to represent a sequence, and then be able to graph it. All right, so what is a sequence? Well, a sequence is a set of numbers in a specific order. Your terms of the sequence would be each number of it. So you would have your first term, which would be the first number in the sequence, your second term, your third term, and so forth, right? And then your arithmetic sequence means that we can add or subtract, and I would highlight or underline or circle those words. For us to know that it is arithmetic, that means that we can add or subtract the same number each time. And we call that number that we are adding or subtracting the common difference. So for example, 3, 5, 7, 9, 11. What am I adding each time? 2. So this would be an arithmetic sequence by 2. 33, 29, 25, 21, 17. What's happening each time? We're subtracting 4 each time. So that would be your common difference. Here it would be -4. There it would be a +2. Okay? So your definition of an arithmetic sequence is, again, where each difference between each numbers is going to be constant. And then we have this really fancy formula with some subscripts. So we have A with a subscript of n. I'm going to be using the word A sub n for subscript of n. That will determine whatever nth term that we are looking for, right? So this should be kind of our output. Think about this as being your output. A with a subscript of 1, so A sub 1 will represent whatever number is your first term, plus n minus 1, where n represents the term number that we're looking for. So if I'm looking for the 5th term, n would be 5. If I was looking for the 6th term, n would be 6. If it was the 7th term, then n would be 7. We would subtract 1 and then multiply it by the common difference. If you guys remember that problem from last week where we forgot to subtract 1, I think it was like the gym membership, and then we didn't include that first one. Well, that's because we forgot to subtract the first term. So that was an example of an arithmetic sequence. So here is one worked out for us. Here's a given sequence of -8, -5, -2, 1, 4, 7, 10, 13, 16. So what's the common difference? What's happening each time? Sometimes it's easier to see it in the positives. What's happening from 4 to 7 to 10 to 13 to 16? We're adding 3 each time, right? So if I wanted to find the 28th term of the sequence, then I'm going to find A with a subscript of 28 is equal to my first term, which is 3, plus 28 minus 1 times 2. And then you'll be able to solve it out to get to 57. Okay?
Wow.
We'll work through it. We'll work through some. You'll see it. All right, so for the first example that we're doing together, guys, all we have to do is decide whether it is arithmetic or not. And then we'll get into actual work.
Yeah, I'd say that one probably is.
So, -4 to -2 to 2, what's happening?
Adding 2 every time.
We are adding 2. So my common difference, which we'll put as a D, is going to be equal to 2. So yes, it is arithmetic, with a common difference being +2. For B, 9 to 4 to -1, what's happening? So this is a yes, where my common difference is -5, because we're subtracting 5 each time.
No.
All right, what's happening with this one?
It's adding 1/4. Right?
Yeah, we are adding 1/4. We're adding 1/4 each time, so that's a yes, where D is equal to 1/4. And then for D, what are we adding each time there? Well, 1/2 plus, so 1/2 is the same as 4/8. So we're adding 1/8 each time.
Well, I don't know if that's true though.
Well, 5/8 plus 1/8 would be 6/8, which reduces to 3/4. 6/8 plus, so what did I just say? Plus, that'd be 7/8.
So yeah.
Yeah, which is, okay, so now let's put it into actual work. So let's find the common difference and then fill in the next three terms. So 15 to 9 to 3 to -3, what's happening?
Subtracting 3.
We're subtracting 3 each time, are we sure?
No, 6.
Good. So we're subtracting 6 each time, which means what would come after -3? -9, and then followed by 15, followed by -21. Perfect. For B, what's happening each time? We're adding a half. So we're eating 1/2, which is the same as 2/4. Let's think about that way so I can have the common denominator. So what's 7/4 plus 2/4? 9/4. Plus another 2/4 would get me 11/4. Plus another 2/4 would get us 13/4. And then 2/3 to 5/6. What is 2/3 with a denominator of 6? 4/6. So how to go from 4/6? Adding a 6 each time? So D is equal to positive 1/6. So what's 1? Well, 1 is 6/6. So what's 6/6? So 7/6. Plus another would be 8/6, which really reduces to 4/3. And then 8/6 adding a 6 would get us 9/6, which reduces to 3/2. So try to put your answers in simplified form. Okay, so can we find a common difference and find the next number in the sequence? Okay, so then where it gets challenging is when you have to find a number way beyond the sequence. You could sit there and figure out each digit of the sequence until you got to the 28th one, but that would be a lot of work, right? So let's turn it into a function, because then I can just put in an input and get an output as an actual function. So for A here, we're looking to find the 18th A. So that means I'm going to do an A with a subscript of 18. So that's telling me I'm going to find the 18th term is equal to, what's the first term in my sequence? 0. Plus, and then we're going to do n minus 1, which my n in this case is 18, minus 1, times, now I have to figure out what the common difference is. So what's happening from 0 to 4 to 8? Adding 4. Good. So if you guys remember back when we did that gym membership problem or whatever it was, this represents like that first month or that first term. These then will represent every term after. So that's why I have to subtract 1, because this already was a term used. All right, so now it's just some multiplication. 18 minus 1 is 17. What's 17 times 4? Is that 68?
Yeah.
So A subscript of 18, so our 18th term would be 68.
Wait, you need that 0?
No, I mean, technically no, but put it there
Okay.
so that you know that that first term was accounted for.
So, what? Oh, so it's just like the first sequence?
Yes. Okay.
So like, okay, so like the next one will be 29 plus.
Right. All right, so for B, we're finding the 75th term. So A subscript of 75 is equal to, first term is 9 plus, then we're going to do 75 minus 1. Now we have to actually think, what's happening from 9 to 3? Subtracting 6. So I'm going to make it a -6. So then we're going to do 94, or 9, plus 74 times -6. Definitely going to need a calculator for that one. So 74 times negative 6 is negative 444. Plus 9 gets me negative 435. So my 75th term would be negative 435.
Wow.
Okay, C. 40th term. So A sub 40 is equal to my first term, which is 1/3, plus 40 minus 1 times, now this is where we have to actually think. So what's happening from 1/3 to a half? Ooh. Let's make common denominators. What will be a common denominator of 3 and 2? 6. So 1/3 would be the same as 2 over 6. 1/2 would be the same as 3 over 6. Then this would be 4 over 6. So now it's a little bit easier to see. We're adding a 6th each time. So my common difference would be 1/6. So 39 times a 6. Definitely going to use my calculator on this. 39 times 1/6. And I'm going to add a 1/3 to that. And then luckily my calculator is able to do fractions for me. Let's see if everybody gets an answer to this. Well, this is 6.5, but then we have to add a 1/3 to that. Test your calculator skills. Can you get to the fraction?
That's crazy. You already done it.
I got 41 over 6. Is that what it is?
My God.
9.5. Nope, that's not right at all.
41 over 6.
41 over 6 is what your calculator should be popping out if you did it with the fractions.
You did it correctly.
If you did it correctly, yes.
I did it correctly. Stupid.
Okay. Questions with any of that?
Sleep? Yeah.
Okay, flip on to the back. Okay, so now we're going to kind of reverse it a little bit. So a sequence 80th term is 293. Its common difference was 3. Find the first term. So if I'm adding 3 each time, I could technically subtract 3, subtract 3, subtract 3, subtract 3, subtract 3, subtract 3 80 times. But that would be a lot of work, right? Or create our function. So a to the 80th term is equal to my first term plus n, which is 80 minus 1 times 3. We were told that the 80th term was what number? 293, so I can turn that a sub 80 into 293 is equal to my first term plus 79 times 3. So now all I have to do is solve that equation for a sub 1. What is 20 or 79 times 3? I heard you, but I didn't hear you. 237. So 293 is equal to a sub 1 plus 237. So what am I going to do to get a sub 1 by itself?
Divide.
Subtract 237 from both sides. So our first term would be 56. So if we started at 293 and subtracted 3 80 times, we should end up at 56.
So then the first.
So your first term would be 56. Yep. All right, so let's set up our equation for B. 21st term is 634 is equal to, our first term is negative 6 plus, what's going to be inside the parentheses? 21 minus 1. And we're solving for the common difference, so we're solving for D. So 634 is equal to negative 6 plus 20D. Can we solve that equation for D? I hope so. What's my first step?
Subtract, multiply We'll add 6 plus.
Add 6 to both sides. So then we get 640 is equal to 20d. Then divide by 20. So what is that? 32? Will be your answer there. Okay?
So D equal 32.
Yes.
And that'd be the first, that'd be the common difference.
That would be your comment. So you'd be adding 32 every time.
Oh my god.
All right, we're almost there. Just going to graph yet. What?
Are you gonna be testing
On Friday. I'll be on your chapter.
this? You have the equation like available.
Okay, so here we go. Graphing. So write an equation, simplify, and then graph. Are you ready?
C.
Okay, so my first term is what? Negative 12 plus n minus 1 times, what's the common difference? What's happening each time? Adding 4. Good. So positive 4. So write an equation. So a sub n is equal to negative 12 plus n minus 1 times 4. Can we simplify that right side? How do I get rid of parentheses?
So you do negative 1n.
Can we distribute the 4 through to get rid of parentheses? Remember we use the distributive property? So 4n minus 4 when we distribute. Then we have a negative 12 plus. Do I have any like terms here to combine? I have a negative 12 and a negative 4, which makes negative 16 plus 4n. So a sub n is equal to negative 16 plus 4n. Out of a sub n and n, which one represents the x? Which one's the independent variable? The a sub n or the n? N. Perfect. So let's cross that off and turn that into an x, which would then make a sub n a sub x or just y, right? Since they have y down here. Either works. So y equals negative 16 plus 4x. So now can we come up with the domain? Can we use any number we want? Yeah, because I'm not dividing anything. So let's do some negatives. Let's do like negative 2, negative 1, 0, 1, and 2.
Perfect.
All right, so let's do some math. 4 times negative 2 is negative 8 plus negative 16.
Is negative
24. That's not fitting on my graph. 4 times negative 1 is negative 4, and a negative 16 makes negative 20. 4 times 0 is 0, plus negative 16 is negative 16. 4 times 1 is 4, and negative 16 makes negative 12. 4 times 2 is 8, so negative 8. Do any of these math fall on my graph? 2 negative 8 definitely does, doesn't it? Can you get 2 negative 8 on there?
I mean,
2, 1, 2, 3, 4, 5, 6, 7, 8.
And maybe we can get.
So can I get another point? What if we plug in 3? Let's add an extra.
What?
What would be 4 times 3? 12. 12 plus negative 16 is negative 4, so we can get 3 negative 4 on there. 1, 2, 3, 1, 2, 3, 4. Now I at least have 2 dots that I can make a line.
Well, you could do 4
And then get another one, sure. Okay, so there we have our graph. All right, let's do the last one. Okay, so we have a sub n is equal to my first term, which is negative 19, plus n minus 1. What's the common difference? Are we adding 6?
Why is there not a number right next to it? What's the...
I'm trying to think of what it is. Is it 6? Is that what we're doing each time? Okay, get rid of parentheses by distributing. So 6n minus 6 Bring down your negative 19 and your plus. Negative 19 and a negative 6 is negative 25 plus 6n. So my equation is y equals, I'm going to put my 6x first, 6x minus 25. All right, let's pick some nice numbers.
1.
If I pick negative 1, I'm going to have negative 6 minus 25, which is going to be really large. If I pick 0, I'm going to have negative 25. So let's go bigger than 0. If I plug in 1, what do we get? What's 6 minus 25? Negative 19. If I do 6 times 2, that's 18 or 12. 12 and negative 25 is negative 13. 3 would be negative 7. 4 is negative 1. 5 is 5. All right, I like these numbers, so I can plot 5, 5. Let's get that on there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4, negative 1. 3, negative 7. Usually 3 points is enough to kind of get a rough idea of what the heck your graph's doing. And then make your line. Okay? Questions?